All right, my ninja warriors, what's up? How is everybody doing and how is your preparation going on? So, you have clicked on this video and you're attending my live session just because you want to revise algebra in one shot. And by revising, I don't mean the revising theory part, but I mean the revising part is done through the help of PYQs or question itself. Okay, yes, all right. The moment you enter the session, what you have to do is you have to smash that like button. Okay, yes, all right. Let me set the frame a bit. Okay, yes, and let me hide the edges. Is it better now? Yes. All right. Okay. Good evening. Screen is black, you are saying? No, I don't think so. Duration of this session also. See, the first two to OBS. The connection is successful now. Hmm. Is it? Is it better now? Yes. So, you know what? While I was stuck, what I was doing, let me tell you. I was doing this speed test. Can you see? Everything is seems fine at my end. The download speed is fine. Okay, you can't see. Sorry. Now you can see. See, I did this speed test. Download speed, upload speed. And then having internet problems, then I clicked possible problems and then I clicked on it and it suggested me that I have mentioned that I have problem with video streaming. And you know what? Can you see YouTube reported in last 24 hours? What is happening? YouTube is reporting so many problems. Can you see? And it is happening maximum problems around 7 o'clock, right? So yes, I think there is some problem with YouTube, correct? But now I think we are good. And are we good? Are we good? Are we good? Tell me. Are we good? Am I now audible? Am I now visible? So please note, if at all something happens, my internet is working fine. My setup is doing great. What is not good is YouTube. If at all there is some issue with YouTube, I'll let you know on the like Telegram. Okay, all right. So let's now hope that we'll face zero technical problems. All right. And if you are new to the channel, if you are new to this platform, this is my brief introduction. My name is Namrata and I have over a decade of teaching experience in both online and offline. Here are my credentials, and today in this particular session, because 99% of you are coming to crack JEE main examination now that you have very less time left, okay, I am going to teach you some techniques, and these are not cheap tricks. These are some fast techniques that will help you to save time if learned correctly and if understood nicely. Okay, all right. All you have to do is click on the what do we say? Click on the like button. All right. And now let me set the agenda of today's session. The session duration, what all topics we are going to cover, are we going to cover theory, are we going to cover questions, and how many marks I can get by attending this particular session, right? Okay, so let me be very honest with you. Ma'am, high percentile is achievable in limited time. What kind of questions are you asking? Can you please play? I'm preparing JE second paper. Be asked. Yes, can be done. Can be done. Okay, believe in yourself. If you are conceptually sound, if your focus is there, then I think it is achievable. Okay. Last U integration. Okay. I addressed you, Louis. Is this class good for IOQM? Let me be very honest. it can stand as a base for IOQM. But let me be very honest, IOQM problems need a deeper level understanding rather than fast solving. Okay, although the topics are same, the concepts are same, but the nature of the problem solving is very different. This can be your base for IOQM examination. Okay, am I stuck again? Happy New Year, everybody. Happy New Year. Chalo, let's start. Let's start. See, what all chapters are there in algebra? I am going to list that out. Number 1, quadratic equation chapter. Number 2, we have sequence and a series. Number 3, we have binomial theorem. Number 4, we have complex numbers. Okay, complex numbers. And number 5, we have matrices and determinants. Okay, so a huge chunk, you know what, a huge chunk over here. And you know what, algebra is scoring as well. Why? Because very elementary kind of chapters. Quadratic equation seems very familiar. If I ask anyone that do you target quadratic equation or integration or calculus chapter, any day any student will pick quadratic equation, sequence and series, and binomial theorem, these kind of chapters over any other chapter, right? So today's session is going to be approximately 3 to 3.5 hours, plus 3.5 hours. Let's see, 3 hours. I'll keep it 3 hours. Okay. And you know what? I was thinking of splitting this algebra in 2 parts, because you know what? Maths is somewhat a heavy subject. Unlike chemistry, in chemistry you can actually go on and studying for long hours, but mathematics requires solving steps and thinking also, so it needs your brain to work very nicely. So in mathematics we'll prefer quality over quantity. Okay, all right. Yes, PNC and probability is there, but I am going to list now the algebra chapters which I am targeting. Okay, now today's session I am going to show you the weightage also, permutation and combination and probability also. Okay, do not worry. Quadratic equation, you know what, 1 to 2 questions you can expect from this particular chapter. Sequence and series, 2 questions every year. Binomial again, 1 to 2 questions. Complex number, 1 question. Matrices and determinants, 3 questions. Okay, alrighty everybody. So now that you know the weightage, today we are going to cover 3 chapters. Okay, I am going to start with quadratic equation, or do you want me to start with any other chapter? Okay, let's vote. Do you want me to start with quadratic equation today or binomial theorem? Okay, quadratic equation or binomial theorem? Vote right now. What do you want? Quadratic, although weightage is pretty much same. So I was thinking of doing quadratic equation, binomial theorem, and you know what, one more chapter I am going to combine with this. That could be complex numbers, or yes, complex numbers. What do you think? So complex numbers, request binomial, request from binomial, binomial, binomial. Okay, I think many students are commenting binomial. Okay, so we'll actually target. So today, let me plan today's session. We are going to target, since this is not a long session, with these 3 hours we will be able to target 4 questions, at least 4 to 5 questions from this session alone. Very small session I'm going to take. So I'll start with binomial first. Okay, once we are done with binomial, we'll target quadratic and complex, because you know what, quadratic and complex are very close chapters to each other. The some problem solving is pretty much similar. So we'll target quadratic and then we'll target complex numbers. Okay, sequence and matrices and determinant we can keep it for tomorrow. What do you think? Yes, all right, because you guys have suggested that ma'am, binomial theorem is what we should start. Okay, and the very important thing, let me tell you that in binomial I am going to share so many of good nice tricks also to solve problems. In fact, in each and every chapters I have got ninja techniques. Okay, all right, I hope you all know about ninja techniques. Okay, so let me just skip everything. Everything we are going to skip, 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 skip. Okie dokie. Where are you, binomial? Sequence and series is going to take a good time. Yes. Binomial theorem. All right. One student is asking a very good question. Please do theory for 10 minutes, ma'am. See, please understand, I know some of you might be thinking, ma'am, you're going to directly talk about problem solving, and what if we don't know what to do? Please do not worry, because whenever we are going to solve any question, I am not going to just solve question and move quickly forward to it, away from it. No, I am going to teach you the exact concept, the exact formula, and the solution part, and if at all there is any trick to solve that problem in a faster way. So basically one problem we are going to pick, but you know what, 360-degree we are going to understand the logic, concepts, everything behind that problem. So do not worry about it. Okay, alrighty, perfecto. Shall we start? Yes. Binomial theorem. Okay, alright. Now this type of question where the number of integral terms is asked. Okay, see, in binomial theorem, I'll list a couple of important things over here. X plus y power n expansion. Can anybody tell me? NC0, x power n and y power 0 plus NC1, x power n minus 1, y power 1. And so on NC2, x power n minus 2, y power 2, and so on NCn, x power n minus n and y power n. Okay, so can you see right now, this is something which is so important in binomial theorem. Okay, x plus y power n expansion over here. Okay, so can anybody tell me how many terms are there in this expansion? Everybody should know that this is the expansion. Can you see the pattern how to expand any binomial using this formula? NC0, NC1, NC2, NCn are the coefficients, right? Then we have x power n minus 1, x power n minus 2, and eventually it will go up to x power n minus n. Can you see now, very important fact, here NC0 and the power of y are in sync. NC1 power of y sync, NC2 power of y sync, NCn power of y is in sync. Okay, so total number of terms we can clearly see is n plus 1. And you know what, general term, first of all tell me that this is first term is having 0, second term is having 1, third term is having 2, so r plus 1 term will have r. Okay, so it is NCr, x power n minus r, y power r. This is your general term, and you know what, 90% of problems are based on this particular formula. 90% problems are based on general terms. Okay, 90% problems are based on this particular formula. Okay, so whenever any formula will need, I will revise like this. Okay, is it like understandable? What do you think? Right, we are going in a right pace. Now some people are actually giving me answer, the number of integral terms. Okay, no, this is not we are going to pick, this is not my very first question. Okay, also binomial theorem, let me first list down what are the important topics in binomial theorem before we jump on to any question. So number 1 is term independent of x. Term independent of x in binomial expansion. The first category, very popular category, NTA's favorite category, term independent of x, type number 1. Okay, second is remainder through or basically coefficient of x power r, coefficient of x power r. Okay, this type of question. Then or term of coefficient of x power r, yes. Then we have remainder problems. Then we have series which involves properties of binomial theorem. Okay, then we have number of integral terms. Mostly, all the problems which we are going to do today in this session is going to fall under one of these categories. What are the categories in binomial theorem? 1, 2, 3, 4, 5. So these are the 5 hot categories in binomial theorem. Okay, 5 hot categories. This is NTA's favorite. Okay, now please understand, I want you all to change the perspective of mathematics. Please understand, we are not going to, yes, one student is saying multinomial. What I have written over here is the hotshot trending topics. Okay, if you are going to ask me, there are at least 20 categories in binomial theorem, but based on the trend analysis, past 10-year trend analysis, there are high chances that your questions are going to fall under one of these categories. 1, 2, 3, 4, 5. 5 categories. Okay. All right. So let's start one by one. I'll keep on reminding. Okay. So the very first question on your screen is going to be from term independent of x. Okay. Term independent of x. Can you see a JEE Main 2025 PYQ? Term independent of x. Now this type of question, high frequency question. If you ask me which is one question which is high frequency question, this is the kind of question. Please ma'am, we don't have no time to analyze trend now. So that's what I am doing. Ignited Rock, what do you expect? I am actually doing it for you. Okay, this is the years of hard work which I have put in, and I am telling you that the term independent of x type of questions are the trending questions. So what are you trying to say? I should not tell you what is the most expected pattern, or do you want me to do all the questions which are not at all like are going to appear in JEE Main? I think Ignited Rockets want me to create one session which is questions that are not going to appear in JEE Main 2026. Is that what you want? Yes, Ignited Rockets, please reply. So I'll just stop this video, and I'll create another video in which I'm just going to talk about problems which are not going to be there in JEE Main 2026. Okay, fine, cool. Ignited Rocket, only you are going to attend that session. Okay, yes. Chalo, let's start. First of all, you will be saying that ma'am, term independent of x in the expansion of this. Okay, all right. So over here you will see this question, and by the way, this question was asked in JEE Main. This is twice the same question, exact same question was asked in JEE Main 2013. JEE Main 2013 question, and then now they are asking in JEE Main 2025 as well. Okay, all right. Now the moment you see this question, you will be like, ma'am, you told us a very generic formula which is x plus y power n. But now what you are showing us is a very complicated expression. This is not even looking like a binomial theorem, ma'am. Okay, yes. So over here, please understand. One student is asking a very good question, ma'am. Please take a session on how to understand a question and how to solve a problem. Okay, so please understand. Pattern recognition is the main key. Why I have written the 5 categories. before I started the session because I want you to think like that. Okay, pattern recognition. So you see that this is something which is term independent of x in the expansion of this plus this power 10. But ma'am, these two things, this expression and this expression looks a little scary over here. So how to solve? So basically this question is less of a binomial theorem, but this question is more about algebra, solving the complicated algebra, basic algebra. Okay, so let's just take this expression x plus 1 upon x power 2 by 3 plus minus x power 1 by 3 plus 1. Correct? This is the expression. Now what I'm going to do is, please understand that over here I'm going to mark this as power 1 by 3 and cube, and here also power cube. So a cube plus b cube, can anybody tell me? A cube plus b cube is a plus b, a square minus ab plus b square, correct? So over here a cube plus b cube is a plus b, so a plus b is x cube plus 1, and now this part, a square minus ab plus b square, so x power 2 by 3 minus x power 1 by 3 plus 1 whole upon x power 2 by 3 minus x power 1 by 3 plus 1. Can you see this whole expression is just x power 1 by 3 plus 1. This particular expression is x plus x power 1 by 3 plus 1. Now let us have a look at this, x minus 1. X minus 1 upon x minus x power half. Okay, so over here if I am going to take this x power half common, what do I get? X power half I'll take common. So I'll be like x power half minus 1. And you know what? This x power half can be written down as half and square. So a square minus b square, anybody? Ma'am, a plus b and a minus b whole upon x power half is already there, and x power half minus 1 is there. So this cancel. So this is remaining. If you divide, it is going to be 1 plus x power minus half. Correct? This is the first thing and this is the second thing. Alrighty everybody. Yes, I can see that you are not able to see that part. So let me zoom out a bit. Is it correct now? Yes. So now this whole expression, which was looking very scary in the beginning, but now this expression has become what? This expression has become x power 1 by 3 plus 1. Okay, minus this is 1 plus x power minus half. And you know what? You have power 10. So clearly this 1 and 1 is getting cancelled out. So eventually you are having x power 1 by 3 minus x power minus half power 10. Now this looks like a binomial expression, right? This looks like a binomial expression, yes or no? X power 1 by 3, x power 1 by 3, okay, x power 1 by 3 minus x power minus half power 10, and we are looking for term independent of x. Now anytime, now we are actually going to start binomial. This is the very first time in this question I am going to touch upon the binomial, because before that what we were doing, we were just doing class 9th and 10th what do we say, expansion, factorization, something like that. Okay, now general term will come into the picture. General term is what? NCR, x power n minus r and y power r. Okay, this is in reference to this. Okay, we know this formula, everybody, general term. Yes, if you expand x plus y power n, you will get this as a general term. Similarly, if I try to talk about general term over here, this is 10 CR, and because n is 10, then x power 1 by 3 power n minus r, 10 minus r, and this is y minus x power minus half power r over here. Okay, so this is what it is. Now you're looking for term independent of x. What do you mean by that? Can anybody tell me? All right. Yes. So over here, x power 10 minus r upon 3. See, collect the power of x, power of x. So x power 10 minus r upon 3, and from here you will realize the power of x is what? So power of x from here is minus r by 2. Okay, so power of x eventually will be what? 10 minus r by 3 minus r by 2, and this should be 0 because we want term independent of x. That means power of x should be 0. Okay, so over here 10 minus r by 3 is equals to r by 2. So 20 minus 2r is equals to 3r. R is coming out as 4. The moment your r is 4, now you know the moment you are going to put r is equals to 4, your x terms are going to go. X terms will vanish. So this is 10c4, and you know what? 10c4, this is also gone, minus power 4. So 10c4 only, tr plus 1, t5. Fifth term is nothing but 10c4, which is nothing but term independent of x. 10c4, my dear students, let me go back. 10c4. So 10c4, let's calculate. 10c4 is 10 into 9 into 8 into 7 upon, this is going to be 4, 3, 2, 1. Correct? So 4 and 2 is gone. 3, 3. 7 3s are 21. 21 into 10, 210. Where are you? Option D. Got it? Yes, absolutely. Same model in Obsession JE series. Yes, absolutely. Alright, so this is how your binomial theorem will look like. Okay? Alright? Yes. Now we are going to talk about the number of integral terms. Another pattern. Okay? Another pattern is number of integral terms. Alrighty? Yes. Number of integral terms. Category number 2. See, I told you, this is what we have done. Number of integral terms is what we are going to do, and you know what? Ninja ma'am is going to have a ninja technique for it as well. Ready for the ninja technique? Okay, some questions will have a ninja technique, some questions will not have ninja technique, so you have to understand it. If every question will have a short trick, then you know what? The whole JEE main mathematics paper can be done in a half an hour. Okay? Yes? Alright. The number of integral terms is the expansion of this. Okay? So please understand, it is very important. I know that Ninja ma'am has told you ninja technique and you have rectification it, that yes, people are answering it very good. But it is very important to know the actual method also. Okay? Yes, because I do not propagate, or I do not say that, I do not preach that only go for shortcuts. Shortcuts are only once you have understood the concept. Okay? That is not the substitute of longer method. Okay? Alright, now number of integral terms in the expansion over here. So first of all, general term I am going to write. Help me in writing general term. So this is this 1016 CR, 5 power half, 7 power 1 by, 5 power half is already there, and you have n minus r. 1016 minus, then you have 7 power 1 by 8 and you have r. Okay. Now integral terms. So I am going to write tr plus 1 one more time. 1016 CR, 5 power 1016 minus r by 2, and this is 7 power r by 8. Okay. Now I think the reconnection is successful, so it will be better. Yes. Now let's focus. What I was telling you, the technique to solve, the proper traditional technique. Okay. 7 power r by 8. Okay. Ma'am, yaar, sorry ma'am, I did. Array, ignited rockets. Chill. Chill pill. Okay. I am Ninja ma'am, I can scold you. I am Ninja ma'am, I can teach you. Okay. And I'll share, I'll send love to you also. Do not worry. Okay. Come back. Now come back. This is very important. Okay. 7 power r by 8. R by 8 should be whole number because you want this whole thing to be an integer. See, understand. NCR is always an integer. If you find out any NCR, 7C2, 7C3, 100C3, 100C99, everything is an integer. You just want these two terms to be an integer. Now, if you want this to be an integer, R could be what? 0. Okay, R could be 8. Basically, R should be multiple of 8. 0, 8, 16 and all the way up to. Okay. But, ma'am, all the way up to where? 1016. Okay. So basically what I'm trying to say is R, the maximum value of R. Okay. OBS Studio, no major. What is happening? I am not sure. YT Live. What to do? Okay. So 128 values of R. Note that all the values of R are even numbers, and you know what? To make this power as even number, you just need R to be multiple of 2. So basically, these two powers are telling you, this power is telling R should be multiple of 2. This power is telling you R should be multiple of 8. So you'll be like, okay, R should be multiple of 8 will be the final common ground. So 128 will be the final answer. Okay. All right. Yes. All right. Now ninja technique. Yes. Ready to learn the ninja technique? Ninja technique says that take the power 1016 and you know what? Divide by the LCM of 2 and 8. Because you know what? You want your power to be multiple of 2 intersection with multiple of 8. So multiple of 2 and multiple of 8, if you take intersection, what you're going to get is multiple of 8 only. So 1 and 1016 by 8. Okay, now you're going to get 127. Now your answer, final answer can be two things, 127 or 127 plus 1. But how will you decide? Okay, how will you decide that whether my answer is 127 or 127 plus 1? For that, all you have to do is, you just have to think about this. 1016 and power of this, 1016 upon 8. 1016 upon 8 is an integer kya? Yes ma'am, is an integer. So that means if it is an integer, then this is your answer. You will pick this. You will reject this. 128 is the final answer. Please note that over here, 1 by 2 and 1 by 8 should be prime numbers. Okay, to apply that shortcut, these should be prime numbers. If they are not prime numbers, okay, not this, sorry. These are not prime numbers, hold on. These should be prime numbers, right? These should be prime numbers, yes. 5 and 7 should be prime numbers. Okay, 5 and 7 should be prime numbers. Ma'am, can't we just find using number of terms formula? Number of terms formula. What is number of terms formula? Do you have any formula like that? I don't have. If you have, please share. Okay, what I know is these two techniques, general term and then figure out what all terms are integers. This is a proper method. And this is the ninja technique. 5 and 7 should be prime. Now somebody can ask me that, ma'am, what if they are not prime? Suppose instead of 7 you get 9, which is not a prime number. What you will do is 9 can be written down as 3 square, and then 3 square will become what? 3 power 2 by 8. So this will be 3 power 1 by 4. Now it has become prime. Now you can apply this technique. Okay. Alrighty. Yes. Clear everybody. All right. Yes. One more question. Okay. The sum of all rational terms. Sum of all rational terms. Okay. So in this case, you can't apply ninja technique. Why? Because ninja technique gives you the number of integral terms. It does not tell you that what all terms are required. Okay. So over here, 2 plus root 3 power 8 rational terms. So again, 8CR, general term you have to write. See, 90% of the problems I'll be writing general term. Okay, 8CR, 2 power 8 minus R, root 3 power 8. Okay, so this is going to be root 3 power 8. So root 3 is this. So this is 4. Correct? Oops. Root 3 power R. No, not 8. Root 3 power R. So this is R by 2. Correct? Now I always told you that start with this. R by 2 should be whole number. So R starts with 0, 2, 4, 6 and 8. Now tell me, if you plug in all those numbers over here, this will always be an rational or integral term. So these are the terms which we are going to take into consideration. If R is 0, so T1 you have to write, then T3, then T5, T7 and T9. Okay, so T1, if you are going to put R is equals to 0, 8C0, okay, 2 power 8 and root 3 power 0. So eventually it is 2 power 8. 2 power 5 is 32, 6 is 64, 7 is 128, 2 power 8 is 256. Similarly, T3, that means you have to put R is equals to 2, 8C2, correct, 2 power 6, root 3 power what, 2 by 2, which is 1, correct. So this is going to be 8C2. You calculate 8 into 7 by 2, 2 power 6, everybody, 32 into 64 and this is root 3. Okay. T5. So you have to put R is equals to 4, 8C4, 2 power 4 and root 3 power 2. Correct. 8C6, 2 power 6. So 2 root 3 power 3. And eventually 8C8 and it is going to be R is equals to 8, 2 power 0 and root 3 power 4. Just solve it, add it, you will get your answer. Yes, all the integral terms. So manual stuff is there. Let me show it to you that what all terms will be there. See, understand. Root 3 square. Right, so it will be root 3. So root 3, this is root 3, 2 by 2. So yes, 3 power 1. This is 4 by 2. This root 3 is gone. Yes, now it's correct. Okay. So basically every term is free. This is root 3, not root 3, just 3 because eventually. Yes, so you're going to solve it, you're going to get the answer. Yes, power of root 3 now corrected. Okay. Alrighty. Another question on same pattern do you want to see? Another question on same pattern? Yes. Okay. Least value of n for which the number of integral terms in the binomial expansion of this is 183. Okay. Alright. So least value of n for which the number of, again, ninja technique is applicable over here. First of all, 7, see this is what? 7 power 1 by 3 and 11 power 1 by 12. Correct? Power n. So I told you that n upon LCM of 3 and 12 is 12. So this is your answer, 183. So your answer will be what? 183 into 12. That's it. Okay. Yes. Easy peasy. Now let me tell you, if not ninja technique, then you have a full-fledged solution over here where you write the general term and then you realize that your R should be multiple of 12 and it being multiple of 12 means this is also parallelly sorted. Multiple of 12 will be multiple of 3 and this power will be a whole number. Okay, so multiple of 12. R should be multiple of 12. So total values of R is what? 183. So you will be like, okay, maths are, and eventually you're going to find. Okay. Okay. All right. Now another type of question. Another category. Okay, slightly different category, but you know what, it is getting mixed with the old category as well. Let me read the question nicely over here. Let the coefficient of three consecutive terms tr plus 1, tr plus 2 in the binomial expansion be a GP. Okay, coefficients. Here they are talking about coefficients. Can you tell me the coefficient of tr will be what? Ma'am, coefficient of tr in the expansion of this will be 12cr minus 1. And coefficient of tr plus 1 is 12cr. Coefficient of tr plus 2 is this. Okay. So 12cr minus 1, comma 12cr, comma 12cr plus 1. Okay. These are in GP, geometric progression. Okay. So 12cr whole square is equals to 12cr minus 1 into 12cr plus 1. Okay. This is what is given to you. Okay. So coefficients are in binomial B in GP and P be the number of possible values of R. Okay. So basically I just need to solve this. That's it. 12cr whole square. So 12 factorial upon r factorial, 12 minus r factorial. Okay, and there is this one more thing, 12 factorial, r factorial, 12 minus r factorial is equal to, now this 12cr minus 1, 12c r plus 1. By the way, you know what? If you open this in this manner, this is going to take some time. But I have a small trick to actually solve such questions. What is this trick? 12 minus r, I am going to keep it up this side. 12cr upon 12cr minus 1 is equal to, now this is 12cr plus 1 upon 12cr. Can I do this, everybody? Can I do this? This is fine or not? Now let me introduce you a property of binomial theorem. Everybody, even if you do not know right now, you'll be able to know. NCR upon NCR minus 1 is going to be n minus this. N minus this whole upon this R. Okay. Alright. So can you see that exactly this is written over here? So 12 minus this, 12 minus this, 12 minus R plus 1 whole upon this thing. And on the right hand side, 12 minus R whole upon this thing which is R plus 1. Okay. Now clearly this is going to be a quadratic equation in R. Quadratic equation in R is going to give you two values of R. Okay. So 12 minus R plus 1 will be 13 minus R upon R, correct? And over here 12 minus R upon R plus 1. Okay. So clearly if I am going to cross multiply 13 minus R plus 1, 12R minus R square. Okay. So 13R plus 13 minus R square and minus R is equals to 12R minus R square. Okay. So it's so good. Minus R square is going to get cancelled out anyway, and this is going to give me, am I doing anything wrong over here? Hold on, let me go back. 12 minus R upon R plus 1, and this is 13 minus R. Hold on, let me check. Okay, yes, we are going on a right track. Oops. Yes, we are going to, can you see that you are going to get 12R? See, I thought I have done a calculation mistake. But can you see that you are getting 13 is equals to 0? What does that mean? No value of R is going to satisfy this. No value of R. Okay. No value of R. That means if I go by the question over here, P be the number of all possible values of R. So P over here is nothing but 0. And you know what? Q be the sum of all rational terms. Now this question again, sum of rational terms. Sum of rational terms. So again, sum of rational terms you will calculate. Okay, and eventually you can give the answer. Okay, good. Correct. So rational term would be what? 4 3s are 12. So I think in here rational term finding is very much easy, not very difficult. I'll show you that rational term. So this is TR plus 1 is equals to 12CR 3 power 12 minus R by 4 and 4 power R by 3. Correct. Okay. So R by 4, R by 3. Clearly your R should be multiple of 12. Okay, so R can be equals to 0 and 12. That's it. So if you put R is equals to 0, you're going to get 12C0, which is 1, 3 power 12 by 4, which is 3, and 4 power 0. So that's it. 3 power 3 plus. Now if you put R is equals to 12, so 12C12 is anyway 1. This is 0 and this is 4 power 4. So this is your answer. 27 and 16. 16s are 256. So last digit is what? 66, yes, option B will be absolutely right, 283. Okay. All right. Yes, another question on your screen. Okay, A and B are the coefficients of 30th and 12th term respectively. 30th and 12th term respectively, correct? In the binomial expression of this. So 30th term, can anybody tell me? 30th term 2n minus 1. 30th term will have 29. Okay, so this is your A. What about B? 12th term 2n minus 1, C 11 is your this. Now 2A is equals to 5B. So 2 times 2n minus 1, C 29 is equals to 5 times 2n minus 1, C 11. Correct? So we just need to solve it. How to solve it? Let's have a look. 2 into 2n minus 1 factorial. Then you have 2n minus 30 factorial. Okay, and you have 29 factorial is equals to 5 times again 2n minus 1 factorial. Then 2n minus 12 factorial. Okay, and 11 factorial. Okay, now this is very important because this might be slightly tricky to solve it. This is getting cancelled out. Yes. Okay, but how about this? So let me just do this thing. Let me just cross multiply 2n minus 12. See, whenever you're stuck in such situations now, all you have to do is open the bigger number, 29 factorial and 11 factorial. Okay, first of all, let me multiply. So this is 2 and this is what? 2n minus 12 factorial. Okay, and 11 factorial is equal to 2n minus 30 and 29 factorial. Let's not forget on the right hand side we already have a 5. Okay. Yes. Now we have to solve this. So first thing is I'll open this 29 factorial which is present on the right hand side. So 5 multiply. Now let's open 29 factorial. 29, 28, 27, 26. Then we are going to all the way up to 12 and then finally we have 11 factorial. Okay, on the left hand side we already have an 11 factorial. So this and this is getting cancelled out. Okay. Now tell me 2n minus 12 and 2n minus 30. Which one is bigger? This one is bigger because you have to subtract even more numbers to get this. So that means this one is bigger. So always open the bigger number. 2n minus 12, I am going to open, then 2n minus 13, okay, then 2n minus 14, and it will go all the way up to 2n minus 29, and eventually this is 2n minus 30 factorial, and right hand side is already 2n minus 30 factorial, right? So this thing is going to get cancelled out, okay? So now, and let's not forget, we have a 2 over here, and on the right hand side we have a 5 over here. Now let us compare, let's do the thing, okay? So over here, 2n minus 12, how many numbers are there? It is 5 into 29, 28, 27, and all the way up to 12, okay? And it starts with 2n minus 12 से लेके 2n minus 29, okay? So over here, 12 and 5. Can I do one thing? Can I do one thing? Yes. What I'll be doing is, I'll be actually, can anybody tell me what is, oh yes, oh, can you see, anybody can notice, this is 2 ones are 2 and 2 6 are 12. So here, instead of having the last number 12, we are having 11 also, yes? And now this 6, I am going to combine it with 5 so that it becomes 30 now. So this 6 and 5, I am going to replace it by 30. So now the situation is changed, my dear students. Oh no, please go away. Okay, this is 2n minus 12, 2n minus 13, and all the way up to 2n minus 29 is equals to 30 into 29 into 28 into 27 and all the way up to 11. Okay, so clearly here there are also how many numbers? Like 30 minus 10. 30 minus 10 is what? 20 numbers. Can you see from 12 to this 20 numbers? 20 numbers. The larger number will become 12, 2n minus 12. So clearly 2n minus 12 is equals to 30. So 2n is equals to 42. N is coming out as 21 from here on comparison. N is coming out as 21 and option D is absolutely right. Okay. So the whole problem is all about solving this nicely and eventually understanding that just 1, 2 and 5, some manipulation is required and you will get your answer. Yes? Alrighty. Okay. And now one student is actually giving a very good idea also that you know that it is going to happen. So why not put n is equals to 20, 19, 22, 21. Hit and trial also works. Absolutely. So yes, sometimes these kind of question, if they are going to give in numerical type, then so you don't have option. Okay, then you do not have option, right? But now you have this thing, so you can actually put the values and get the answer. Okay, all right, another question on your screen. Perfect. Let the coefficient of 5th, 6th and 7th terms in the binomial expansion of this are in arithmetic progression. Okay, so 5th term, n plus 4, 5th term will have n plus 4 C4. 6th term will have n plus 4 C5. And you know what? N plus 4 C6. These three terms are in arithmetic progression. Okay. So double of middle is equals to sum of two extremes. Okay. Now what I'm going to do is, again, one method is just open it right away, but you have a like properties, use those properties. What are those properties? Just divide this whole thing by n plus 4 C5. Okay, so what you're going to get is 2 is equal to n plus 4. Can you see that over here? If I just do this, n plus 4c5 upon n plus 4c4 plus this is n plus 4c6 upon n plus 4c5. Let me remind you the property one more time. NCR upon NCR minus 1. N minus this upon this. Correct? So over here, please understand NCR upon NCR minus 1. Basically, this is 5, 4. Yes, ma'am, good to go. So this is 1 upon, can you see now? N plus 4 minus 4. N plus 4 minus 4 is what? N. Whole upon you are having just 5. So basically this 5 will anyway come over here. Plus. Now this is what? N plus 4 minus 5. N plus 4 minus 5 is n minus 1. Correct? And we have upon 6. So this is what we are going to get. Let me write it one more time. 2 is equals to 5 upon n is equals to n plus n minus 1 upon 6. Now tell me, what could be the value of n? Think about it. The value of n, very simple. Can I say that n is equals to 3 is going to satisfy this? Or you have other option as well. Okay, what you can do is solve this using quadratic. But right now, can you see 5 by 3? And this is what? 3 minus 1. 2 by 6, 1 by 3. 5 by 3 and 1 by 3 is what? 5 by 3, 1 by 3 is 6 by 3, which is 2. Yes, ma'am, n is equals to 3. The moment you got n is equals to 3, okay, largest coefficient in the expansion of this, okay. So expansion of this will have n plus 4 CR. So this is going to be 7 CR. Okay, now largest of this you will have when R is the middle of this, 3.5. But ma'am, R cannot be 3.5. So 3.5, so you either go with 3 or 4. Basically, if at all the middle value is not an integer, then you either go with slightly lower integer or slightly higher integer. So 3.5 will be either 3 or 4, but both will give you same answer. So 7C3, my dear students, is what? 35 if you're going to solve. Okay. Both 7C3 and 4. Okay. Both are 35. Alrighty, everybody. Yes, getting it. Now we'll do some couple of questions on remainder also. Okay, remainder problems. Ready for the remainder problems? Yes, my dear students. No, actually one more question before. Okay, one more question. Actually one more need. There is one more category. Properties and series based problem is also very popular. So yes, if the arithmetic mean of all the coefficients in the binomial expansion is 16, arithmetic mean of all the coefficient. What is arithmetic mean? Sum of all the terms divided by number of terms. Sum of all the terms. So 2n minus 3c0, 2n minus 3c1, and all the way up to 2n minus 3c, 2n minus 3. Sum of all the values divided by number of terms. Can anybody tell me how many number of terms will be there? And this arithmetic mean is given as 16. Help me. What are the number of terms? Everybody in the chat box. Yes? Number of terms are always n plus 1. So 2n minus 3 plus 1, my dear students. Yes. So many of you are wrong. Sabrinathan, what happened? Flying chappal, flying slaps. What do you want, huh? Chalo. Now, can anybody help me with this sum? Okay, let me tell you. NC0 plus NC1 plus NC2 and all the way up to NCN is what? 2 power n. How many of you know this property? First property of binomial theorem. I'm going to list all the properties over here in this slide. So sum of this is going to be 2 power n. N here is 2n minus 3. Whole upon this is 2 and this is 2n minus 2. Correct? This is nothing but 16. Okay. And now this is 2 power 2n minus 3 and this is what? 2 power n minus 1 is equals to 16. Tell me what could be the value of n. Think about it. Very easy. N could be, first of all, please understand this n should be an odd number. Why? Because if n is odd, n minus 1 will be even. Correct? N minus 1 will be even. Right hand side is even. You can't make any number odd on the left hand side. Correct? N minus 1, think all the odd numbers now. So if you put n is equals to 3, suppose, then 3 2s are 6, 6 minus 3. So this is going to try with n is equals to 3. So okay, 3 2s are 6. So 2 cube upon this is 3 minus 1. So 2 square. No ma'am, this is not working. N is equals to 5 then. 5 2s are 10. 10 minus 3 is to 2 power 7. N is equals to 5 is going to be 4. Correct? So this is 2 square. So this is 2 power 4. Yes ma'am, it is working. Yes. So n is equals to 5, acceptable. The moment your n is 5, 5 2s are 10. 10 minus 1, so this is 9. 25 minus 40. Sorry, 21. So this is 9, 5. Okay. So now distance of 9, 5 from this line. 9, 5 is 9 plus 5 minus 8 by root 2 is the perpendicular distance, everybody. Let's not forget the mod. So this is what? 6 by root 5. 6 by root 5 is what? Sorry, root 2. 6 by root 2 is what? Root 2 if you multiply. This is 3 root 2, option D. Yes? Okay. Another question. Now this is also a very important type. Okay. Ratio. They are going to talk about ratio. Whenever they are going to talk about ratio, remember that ratio property. Okay. Remember that ratio property. So over here in the expansion, the ratio of 15th term from the beginning. Now 15th term from the beginning they are asking. So remember to write T14 plus 1. And you know what? R will be 14 over here. Please understand. Are you understanding this? By the way, we didn't discuss this. Whenever you have to calculate the 17th term, your coefficient will be NC16. Please remember that. Whenever they are asking that 15th term, so it will be NC14. 2 power 1 by 3 are so 2 power 1 by 3 n minus 14 and 1 by 3 power 1 by 3 power, okay, what is going to be there is 14. Okay, now 15th term from the beginning. Now there is one ninja hack to solve such questions. Let me tell you. If they are asking you 15th term from the end, so if you Google it right now, please Google it. 15th term from the end in binomial theorem, they will give you a formula. I think now I am back, huh? Yeah, I am back, but I feel that, what do you think? Shall we? Okay, let's do one thing. Let's complete binomial theorem, and tomorrow we'll be doing the rest of the chapters. What do you think? Yes? Let's complete binomial. I know we are facing glitches, but let's complete binomial theorem. Okay? Yes? So over here we can see this is your 15th term from, okay, yes, this is what we have missed. Ninja ma'am is coming for a rescue, because you know what, let's redo this question one more time from the top. In the expansion of this, ratio of 15th term from the beginning to the 15th term from the end is 1 by 6. Now 15th term from the beginning though we can write, ma'am. Okay, but 15th term from the end? Huh? What about that? So 15th term from the end has a very big formula which we do not need to learn because Ninja ma'am is here. Ninja ma'am is saying 15th term from the end is equals to 15th term from the beginning with a little bit difference over here. We just need to switch this. Can you see? The moment you're going to switch this, this is what you're going to get. Okay, switching happened. Can you see? Now 15th term of beginning. Now can you see I have actually done nothing. 15th term from the beginning of this is this. Now you just need to switch these two things. So this is what 15 terms from the end. And now, yes, Sabrinathan is telling a formula also. But you know what? You don't have to learn the formula. This is the same thing. And you know what? If you're going to divide clearly, these two are going to get cancelled out. And eventually, can you see that this is going to be, if you divide, can you see if you divide, this is nothing but 2 power 1 by 3 and this is this. So 6 power 1 by 3 power n minus 14 if you divide. And what about this? Can you see if you divide this by this, this is 6 power 1 by 3 by 14 and that is nothing but 1 by 6. So from here, if you again target this, okay, so this is, if you are going to again resolve it, your answer will be what? 6 power 1 by 3 power n minus 14 is equals to 6 power minus 1. Correct? So if you compare n minus 28 upon 3 is nothing but minus 1. So n is going to be what? 31. Correct? N 31. So 31C3. Now you can calculate 31C3. Okay. So 31C3 is going to be what? Minus 1. Minus 1 is there. Oops. Minus 1, right? So minus 3. So n is 25. So 25C3, not 31. 25C3. And the moment you're going to solve for 25C3, you're going to get the option B as the final answer. Okay. All right. Yes, 25. All right, now the next question on your screen. Now, shall we do the remainder problems? Ready for the remainder problems? Ready for the technique as well? Okay, so this is the remainder problem and you know what? Ninja technique you have. Yes, ninja techniques. Remainder, when 64 power 64 is divided by 7, what will be the answer? So you know what, in such cases, do not think about power, think about base. Think about what will be the remainder when 64 is divided by 7. So ma'am, the answer is 1. Correct? So 1 power, whatever is there. Okay, whatever is there. Please write, this is your final remainder and this is nothing but just 1. Option D is absolutely right. Now, obviously, you are going to ask me that, ma'am, right now the remainder is 1. That is absolutely fine. But what will happen if remainder is not 1 and other than 1, other than anything else, right? Like remainder could be 2 or 3, okay? So, in that case, what to do? Correct? Okay. So, the remainder when 7 power 103 is divided by 23. Okay. Well, how to handle such questions, ma'am? Right or wrong? Okay. So, over here we need to understand that 23. Okay. So, 23 and 7. What is the correlation between base and this? That we need to think. Okay, the thought process gradually you need to understand. So ma'am, 7 and 23 directly I can't find any correlation, right? So you know what, now the next step will be to think about how about 7 square, 49. 7 and 23 you need to think. So ma'am, right now we are not able to figure out. Then 7 square, 49 and 23. Is there any correlation between 49 and 23? So ma'am, yes, slightly there is 46. 23 is close, like 23 ones are 23, so 23 is 46. Understand? Here this particular 23, which is nothing but dividend, right? Or divisor. Okay, yes, divisor. So divisor, you have to think that your divisor should be in multiple, 23, then 46, like that. Okay, so 23, 46. I think 46 is very close to 49, but that will actually leave me with 3. 3 is very big number. I don't want to play with 3. So if 7, 49, here in 7, dividend you have to play with the powers. Are you understanding my point? So 7 I am going to increase the powers, and 23 I am going to multiply with the numbers. 23 ones are 23, twos are here 7, 7 square, 7 cube, 343 and 23. Is there any close correlation between these two? Let's find out. So 23 ones are 23, then 46, then we have 23 into 5. If I say 5 threes are 15, 5 twos are 10, 11. Okay, 23 into 15. Okay, so 115. 115 plus 115, can anybody tell me? So this is 113 and this is 230. Okay, so 115 into 3. 5 threes are 15. 345. Oh, I can see 345. Now can you see there is a close correlation found? Okay, basically 23 into 15 is nothing but very close with 343. Now we have got the relation. Okay, now what to do? Basically I will have to write 7 in power of 3. So 7 power 103. Tell me how to write in terms of 343. So for that you need 7 cube. 7 cube, how will you get? 103 is multiple of 3? No. So you have to write 7 power 1, 7 power 102. Why you are doing this? Because 102 can be divided by 3. 102 is multiple of 3. So now this is what? 7 power 1 and this is 7 cube. And you know what? If you divide it by 3, 3 and this is 34. Okay, 7 power 1, 7 cube power 34. Okay, so this is your 7 and this is your 343 power 34, correct? Now again, now your agenda is to write 343, but eventually you have to write in terms of 345 minus 2. Okay, or what you can do is, I told you, see, now you divide 343. Now you divide 343 by 23. What are you going to get? Minus 2 will be the remainder, right? Because you know what? If you divide 23 by 345, you know it is fully divisible. So what is the error over here? 345, 343, ma'am, minus 2 is the error. So minus 2 will be the remainder. Minus 2 power 34 is the answer over here. Are you understanding it now? Yes. So now you have to deal with what? 7 into 2 power 34. This is what you have to deal. Okay. Now again, this is a new number. Okay. You have got your new number. 7 into 2 power 34 when divided by 23. Now this is a new question. You have to rethink about it one more time again. Okay. So 2. 2 is very close to 23. No, ma'am. So 2 power 1, 2 power 2, 2 power 3, 4. So you will realize that 2 power 4 is 16, very far away from 23. 2 power 4 will be 16. 2 power 5 is 32, again not very close. Then we have to go ahead You have to move ahead, okay? Because you know that 23, if you go by 23, so 23 table will have 253, okay? Can you see 23? 253 is basically a multiple of 23 is 253. And you know what? Power of 2, 2 square, 2 cube, and eventually 2 power what? Something, which is 2 power 5 is 32, 6 is 64, and 7 is so 2 power 8. 2 power 8 is 256. So now again you have got a very close relation, okay, which is 3. Can you see 3 over here? So yes, now 7, and this is 2 power 34. So eventually 2 power 8 you have to write. So for that 4 and 2 power 32. Okay, then divided by 23. So 7 fours are 28, and 2 power 32 is actually 2 power 8. 8 fours are 32. Correct? So 28, and this is 256 power 4. Now divide by 23. Okay, so what will be your remainder? You know that 253. So minus 3. So 28 into minus 3 power 4 will be the remainder, or you can say 28 into 3 power 4 is what? Finally 81. Yes. So now though you have full-fledged number. 28 into 81. 28 into 81, so you can figure it out when divided by 23. Okay, so divide by 23 now. So 23 and 8. So 5 from here. Okay, and if you divide this by 23, so 23 threes are 3 threes are 9, 3 twos are 6. Yes, 23 into 4 now. 4 threes are 12, and 4 twos are 8, 9, 92. So I think this is wrong. And 69 and 81, if you subtract, remainder I am looking for, okay? So it is going to be 10 and 12. So this is your 60. Okay, so now again divide by 23. So what you're going to get is 46. Correct? 46. So 14 will be the remainder. So finally 14 is the final remainder. 14. Slightly lengthy, okay, but the technique you have to understand. Okay. All righty, everybody. Yes. So I think binomial theorem from my side is done and dusted. Okay. And now we are actually able to beat the technical part. So shall we go with quadratic equation now? Yes. How many of you are quadratic equation ready now? Okay. Yes. So let's do quadratic equation at least today. Okay. If not everything, let's see. Good to go. Okay. Now quadratic equation is slightly easier than dinner break you want. No. 30 minutes later we can keep dinner break. What do you think? Okay, I think we'll be able to finish quadratic in 30 minutes. Okay. All right. Chalo, let's start. Again, let me dissect the quadratic equation now, by the way. Quadratic equation. Relation between roots and coefficient. Okay. Then we have location of roots. So we have Newton's formula. Then we have modulus based. And then we have location of roots. And then we have quadratic Basic types. Okay. All right. So over here, again, they are talking about the quadratic equation is given to you, and they are talking about alpha power 4 plus beta power 4. First of all, alpha square, see alpha power 4 plus beta power 4 is going to be alpha square plus beta square power 2 minus 2 alpha beta whole square. Yes or no, everybody? Yes? And you know what? Alpha square plus beta square is nothing but alpha plus beta whole square minus 2 alpha beta. Okay? So now we can actually calculate first alpha square plus beta square and eventually put the value over here. Okay? So alpha square plus beta square is alpha plus beta. Can anybody tell me what is alpha plus beta? Sum of roots minus b by a, and product of roots is c by a. Let's put the value. So this is cos square theta by 4 and minus plus 1. This is alpha square plus beta square. Right now let's put 1 plus cos square theta by 4 whole square minus 2, and this is 1 by 4, so minus 1 by 2, correct? This is this thing which basically you are looking for. Let's focus on this. Okay. Now what they are asking is maximum and minimum value. Okay. So minimum value I am going to write here. Maximum value I am going to write here. Let's think about minimum value. See, understand, in this whole situation, this is fixed. 1 is also fixed. 4 is also fixed. The only thing is this, which is not fixed. Now, if you want minimum value, cos square theta should be minimum, and the minimum value of any squared quantity is 0. That means 1 square minus half. So half is the minimum value. For maximum value, you have to put it as 1. So 1 plus 1 by 4 whole square minus half. So this is what? 25 by 16 minus half, and you know what? 16. So this is 9, 16. 25 minus 16 is 9 or not? Sorry. 25 minus 8. So this is 17 by 16. Okay. Now 16 times 1 by 2 plus 17 by 16. This is nothing but 8 plus 17. 8 plus 17, my dear students, is going to be 25. Easy peasy? Yes? Okay. Alrighty. Clear? Next question on your screen. And so these type of questions. Okay. These type of questions. Can you see? 9 by x, okay, minus 9 root x plus 2 over here, okay. So here I can see that 1 by root x is equals to t is going to be the smartest decision ever. So that is going to give me 9, okay, 9t square minus 9t plus 2. And what about this? 2t square minus 7t plus 2 plus 3 is equals to 0. So from here 9 2s are 18 and 18, 9 2s are 18. So 6 3s are 18. Yes. Quadratic equation 9t square minus 6t minus 3t plus 2 is equals to 0. So if you take common, this is 3t minus 2 and 3t will come out minus 1. 3t minus 2 is equals to 0. So clearly t is going to be 1 by 3 comma 2 by 3. Okay. T is 1 by 3 comma 2 by 3. Correct, from here at least. And what about this? 3 2s are 6. 2t square minus 6t minus t plus 3 is equals to 0. So again 2 t, t minus 3 and minus 1 t minus 3 is equals to 0. Clearly t is equals to 3 comma half. Okay, if you put your t over here, 1 by 3, so your root x is 3 comma 3 by 2. Correct? So x is going to be 9 comma 9 by 4. And from here, x is going to be what? 1 by 9 and x from here will be 4. Can you see how many solutions are possible? Yes, my dear students. 4 solutions? 0 and 2 pi not included, na? Oh, you're talking about the next question. Here there is no role of 0 and 2 pi. Anyway, yes. Alright, another question on your screen. The product of all the solution of this equation, okay, so e power 5 ln x square plus 3 is equals to x power 8. Now, if you take log both the sides, what will happen? This whole power will come in front. So, 5 log of x whole square plus 3 is equals to 8 log x. If you put log x as t, this is going to be, so 5t square plus 3 is equals to 8t, okay. 5t square minus 8t plus 3 is equals to 0. Now please understand, there are two ways to go about it. One way will be calculate the value of t and eventually the value of x. Another way would be that you have t1 and t2 are the roots, which is ln x1 and ln x2. What do you want? You want product. You want x1, x2. Okay, so understand, you have to think one step ahead. Log x1 plus log x2 is actually nothing but log of x1, x2. Log a plus log b is log ab, correct? So that means we need to find out log x1 plus log x2, which is nothing but t1 plus t2. And t1 plus t2 is the roots of this equation. Sum of roots is what you are interested in, not the product. Finally, you will get the product, but here you are interested in sum of roots, which is 8 by 5. So t1 plus t2 is nothing but log x1 plus log x2, which is nothing but log x1, x2, which is 8 by 5. This is also 8 by 5. Now you take anti-log. So it will be e power 8 by 5 is equals to x1, x2, and that is done. Because Pushpa, Raj, tell me cos, even though 0 and 2 pi is not included, but pi by 2 is included, right? Pi is included. Cos pi by 2 is 0. So cos theta can be 0. And cos pi is included. Cos pi is minus 1. So cos square theta will be minus 1 square. So it can still be 1. Right? Yeah, right, Pushpraj? Correct or not? Okay. Another question. Now this time another different question. Can you see product of all the, again, x square minus 9x plus 11 square minus, can you see x square minus 9x plus 20 is equals to 3. Now anybody who has good observation skills, who will understand x square minus 9x, if you are going to put as t, then it will be what? T plus 11 whole square minus t plus 20 is equals to 3. Now this is very like easy. Right now it is power 4 equation, but this has become power 2 equation. So this is t square plus 121 plus 22t minus t minus 20 is equals to 3. Okay. Alright. So now you're going to have t square. Okay. Then we have plus 21t. Okay. Yes. And we have 121 minus 20, 101. 101 minus 3 is 198. So plus 198 is equals to 0. Okay, so now you have to actually solve for a t, right? Is it 100 and hold on, not 191, just 98. Okay. Now you have to just solve for t. So if you are going to solve for t, yes, 14 into 7, right? And we have t plus 11, yes. So t plus 14 and t plus 7, correct, is equals to 0. So t is going to be minus 7 comma minus 14. Now what is t? So x square minus 9x is equals to minus 7. This is one quadratic equation. X square minus 9x is equals to minus 14. This is another equation. Two equations, right? X square minus 9x plus 7 is equals to 0. X square minus 9x plus 14 equals to 0. Yes? Okay. So now this is x is equals to 9 plus minus square root of b square, which is 81 minus 4, 81 minus 28. 81 minus 28. So this is 3 and 53. Yes, 7 minus 2, 53. Root 53 by 2. What about this? X is equals to 9 plus minus b square. 81 minus 4 into 14. 56 upon 2. Correct? So this is what? 5, right? So anyway, whatever the value will be, let me show it to you. The calculation I have already. So one is 53, another will be, okay, 25, right? So 9 plus minus 5 by 2. So 9 plus 5 is 14, 14 by 2, 7. 9 minus 5 is 4 by 2 is 7 comma 2. So we can clearly see that rational roots 7 comma 2 are the rational and this is irrational. 7 2s are 14. So option A is absolutely right. Yes. So these kind of questions which are not heavy on concept but actually doable, if you tell me. Okay, now modulus based questions. You might be able to see modulus based questions in JEE Main 2025 for sure. 2026. 2026. Okay, yes. Now it's better, right? Okay. So yes, let me explain you what we have done so far. I have taken a case 2x minus 3 positive, x greater than or equals to 3 by 2. Okay. Then we have this quadratic equation, right? Because the modulus is positive and now this is positive, so you have to open it. You will see two roots. One root is completely negative. You don't have to calculate because you know what, your x should be greater than 1.5. So clearly this is rejected, but this is 1.4 into 2 minus 1. So this is what? Basically 1.4. This is what? 2.8 minus 1 is 1.8 basically, which is acceptable. And same. Now here x square minus 2x plus 3 minus 4 is equals to 0. So this is x square minus 2x minus 1 is equals to 0. Okay. Alrighty. So now we are having x square minus 2x minus 1, correct? So this is 2 plus minus square root of b square. So plus 4. So 4 plus 4, 8 by 2. So if you solve it, it is 1 plus minus, this is root 2. Okay. So 1 plus root 2 will be rejected. 1 minus root 2 is that number which is over here. So this and this, now sum of the squares. So 2 root 2 minus 1 square plus 1 minus root 2 square will be your final answer. So this is 8 plus 1 minus 4 root 2. And this is 1 plus 2 minus 2 root 2. Okay. So this is 8 plus 1 and this 8, 9, 10, 11, 12. 12 minus 6 root 2. If you take 2 common, okay, it's important. If you take 6 common, clearly option C is absolutely correct. Okay. Alrighty. Alright. Yes. Now the Newton's formula. Ready for the Newton's formula? Ready for the Newton's formula? Yes. This is a question from Newton's formula, and you know what? Every JEE aspirant should be able to answer this. How many of you can answer this? How many of you can answer this? Yes? Okay. Alright. Your favorite? Yes, Sabri. So answer it. Newton's formula says if you have got any quadratic equation and you have an expression of the type, oh, I have zoomed a bit, okay. What is happening? A quadratic equation, and you know what, roots are alpha and beta, and this expression is given. So all you can do is you can actually rewrite this quadratic equation by replacing x square by pn, x by pn minus 1, and multiplying constant by pn minus 1, pn minus 2. Basically, you just multiply all the coefficients with the respectively consecutive pn. Let me tell you what I'm trying to say. See, this expression is all about p. The maximum value of p is 25. So here I'll start with p25. This is coefficient is 1. 1 multiply p25. Root 3 multiply p24. 16 multiply p23. This is 0. Okay. So p25 plus root 3 p24 is going to give you what, ma'am? 16p23, and 2p23 is already there. So clearly 8 is the answer. Similarly, over here you have got the second quadratic and qn associated to it. N is also 25 over here. So q25 plus 3q24 minus q23 is 0. So q25 minus q23 is minus 3q24. So minus 3q24 upon q24. So clearly this is minus 3 and this is 5, option C. Okay. This is what Newton formula is. Okay. All right. Then we have one more question on Newton's formula. Or not, I am not sure. Let's see. Slightly different this time, huh? Slightly different. Usually Newton formula question will be easy, but sometimes they might give you these type of questions as well. Okay, so x square minus ax minus b is equals to 0. So this time they are not giving you coefficients, and rather they are giving you p3, p4, p5 and p6. So let me do one thing. Let me actually write the Newton formula equivalent of this equation, and you know what, let me start with p6 now. So p6 minus a p5 minus b p4 is equals to 0. This is your first equation, and you know what, I can write another Newton's equation, which is what, p5 minus a p4 minus b p3 is equals to 0. This will also work. Okay, now let me put the values and get two equations in terms of a and b. Basically, this whole question is all about calculating a and b. That's it. So you just need two equations. P6, everybody. So 45 root 7 iota minus a p5. 11 root 7 iota minus b p4, which is minus 3. So 3 root 7 iota is equals to 0. Clearly, root 7 iota, root 7 iota, root 7 iota is gone. So you are left with what? 45 is equals to 11a plus 3b. Now this p5, everybody, 11 root 7 iota minus a p4, so plus 3 root 7 iota and plus b 5 root 7 iota is equals to 0, root 7 iota, root 7 iota, root 7 iota. 11 is equals to 11 plus 3a plus 5b is equals to 0. 3a plus 5b is equals to minus 11. Okay. All right. Yes. So now this is very easy. Calculate the value of a and b. Okay. A and b. Once you are done with that, then you know the equation. Now can't you calculate alpha power 4 plus beta power 4? Tell me. Ma'am, minus 3b. What minus 3b? Yes. Minus minus became plus, na? So plus 3b. Hold on. The first is 45. Minus 3b. Oh, yes. Yes, yes. Okay. Now solve. And this is done and dusted. So this is Newton's formula plus you have another which is relation between roots and coefficients. Right? Okay. Alrighty. Okie dokie. Yes. And now let's talk about another chapter, okay, which is complex numbers. Ready for complex numbers? Okay. Yes. Ready for complex numbers? Everybody? Okie dokie. This question. Okay. Right. So this question. Understand, let the product of W1 and W2 be alpha plus iota beta. Okay. So let me write W2 here, W1 omega 1, also they can say 8 plus iota, or rather let me write the omega 1 slightly in a different manner. This is a very basic question. This is a very basic question. Do you want a break? Let's take a 15 minutes break. We'll come back and we'll finish complex numbers and then we'll be done for today. Tomorrow we'll talk about sequence and matrices and determinants. Okay? Chalo, let's take a break. numbers, right? Okay, so I think this will be the last chapter in today's session. Tomorrow we are going to continue with sequence and series and matrices and determinants. Okay, all right, so let's quickly just do it, and before time, let's sleep it today. Okay, yes, ma'am, can you check out Mathesy and 3 blue and 1 brown in free time? Yes, absolutely. Louis, you are actually very early are able to see such good content, and yeah, that's great. Okay, now you know what this omega 1. Omega 1 is what? Please understand, now I am going to write omega 1 as a real part plus iota times imaginary part. Okay, let's do it. So 8 sine theta plus 7 cos theta, correct? This is your real part plus iota times, it is sine theta plus 4 cos theta. Everybody correct? Okay. Omega 2 over here in similar is sine theta plus, it is going to be 4 cos theta, correct? Plus iota times, this is 8 sine theta plus we have 7 cos theta. Alright, can you see this is real part is exactly same as imaginary? Here imaginary and real. Okay, all right. Now omega 1, now what they are saying is product omega 1 omega 2. Okay, let's start. First of all, understand we have to segregate the real and imaginary part of product also. Can you see that product we need to write in this particular format? So think about it. If I am going to multiply these two terms, so first real part will get multiplied. So the moment I am going to multiply real part with real part, I am anyway going to get the real part. So let's do that. So this is going to be 8 sine, okay, plus 7 cos, and this is sine plus 4 cos, correct? And you know what, now I am going to be, so this is real part is alpha. So I am going to actually talk about alpha only. Let's figure out alpha. How will you get real part? When you product it, when you multiply it. So you will get real part if you are going to get multiplied real part. And you know what, if you are going to multiply both the imaginary part, what will happen? Iota will get multiplied with iota, and iota square is minus 1. That means the moment you're going to multiply these two expressions, you are going to get a real part. Okay, so which is minus will be there because iota into iota is iota square, which is minus 1. So let's multiply sine plus 4 cos and 8 sine plus 7 cos. Can you see? Can you see that alpha is coming out as 0 without even doing anything? You don't have to solve it completely. Okay. Alpha is 0. Now beta, everybody beta. How will you get beta? What is beta? Beta is a term which is multiplied with iota. So you will get iota term if you are going to multiply real part with imaginary and real part with imaginary. So this is going to be 8 sine plus 7 cos whole square. So 8 sine plus 7 cos whole square plus, if you multiply this, sine plus 4 cos whole square. This is your iota term which is beta. Okay, so now solving this also is not a very difficult job. This is 64 sine square plus 1 sine square, so 65 sine square, plus this is 16 sine square plus 49. 49 plus 16 is again 65 cos square. Sorry, cos square. Okay, and now see a square plus b square terms are done. Now 2ab. Okay, so this is 8 7s are 56. 56 into 2 is going to be 112. Now this 4 2s are 8. So 112 plus 8 is 120 sine cos. Correct or not? Now this is what? 65 plus 120 sine cos is your beta. Now what they want? P and Q be the maximum and minimum values of alpha plus beta. Please understand, alpha plus beta is beta only because alpha is 0. So 0 plus 65 plus 120 sine cos is 60 sine 2 theta. This is your alpha plus beta. Now tell me one thing, maximum and minimum value. So for minimum value, sine 2 theta will be minus 1. So 65 minus 60 will be 5. That is going to be the minimum value. Okay, so Q is 5. And for maximum value, sine 2 theta will be 1. So it is going to be 125. So final answer is 130. Where are you? Option A. Okie dokie. Yes. So this is a very simple question, as you can see. Okay. Now another question on your screen, which is this. Okay. They are going to talk about real part. Okay. Understand that what they are saying is, this is your set A, wherein this is the condition 10 times real part of this. Now can anybody tell me what is the real part of this? So let's focus on the real part of this, especially this. Especially I am going to target this. So 2 cos plus iota sine upon cos minus 3 iota sine. Okay. Alright. So this is going to give you cos plus 3 iota sine, cos plus 3 iota sine. Alrighty. Yes. And now this is what? Cos square. That's how you, first of all, I am expressing this in terms of a plus iota b. Once I am having that a plus iota b format, then it is very easier for me to segregate the real part. Okay, so I am just trying to remove the iota thing from the denominator. For that I will have to rationalize it. That means not rationalize, but we need to multiply with the conjugate. Okay. Yes, so this is a plus b, a minus b, cos square plus 9 sine square. And this is what now you are looking for, the real part. So real part, now finally I am going to write only the real part. So real part you will get when you multiply real and real. So 2 cos square. And you multiply imaginary to imaginary, so minus 3 sine square. Okay, so this is what we are going to get. Now 2 cos square minus 3 sine square is your real part. So what we can do is, here also we have a very good scope. Okay, so let us keep this in terms of cos only right now. So 2 cos square minus 3, 1 minus cos square. Okay, this is your again cos square, right? So cos square plus 9, 1 minus cos square. Everything I am converting in terms of cos. So this is 5 cos square minus 3. Okay, whole upon, can you see this is 9 minus this is 1 minus 9. 1 minus 9 is 8 cos square. This is your real part. Okay. Now what they are saying is 1 plus 10 times real part is equals to what? 0. Correct. So we just need to solve it, minus 1 by 10. So this is going to be actually minus 1 by 10. Now cross multiply. So this is 50 cos square minus 30 is equals to minus 9 plus 8 cos square. So this is nothing but 42 cos square is equals to 30 minus 9 is 21. Okay, cos square theta is half, my dear students. Cos square theta is half. That means cos theta is nothing but plus minus 1 by root 2. So cos theta, theta here is multiple of pi by 4, my dear students. So over here, what all multiple of pi by 4s are available? Let me tell you. Pi square by 4, pi by 2 whole square plus 3 pi by 2 whole square plus we have 5 pi by, 4, 5 pi by 4 whole square, and then we have 7 pi by 4 whole square. Right or wrong? In 0 to 2 pi, you will see pi by 4, 3 pi by 4, 5 pi by 4 and 7 pi by 4. So this is your answer finally. So 49 plus 25. First of all, 49 plus 1, 50. And this is what? 25 plus 9. So 50. So 25 plus 9. 25 plus 9, 34. Correct? 50 plus 34, 84. 84 by 16. 84 by 16. Okay. Pi square is the answer. So now 4 4s are 16. 4 1s are 4. 21 pi square by 4. Option A is absolutely right. Yes. Correcto? Correctamundo? Everybody getting it? See now this question. Now this question, JEE Main 2025 PYQ, but it will look like it is an easy problem. Z square plus 3 iota. Can you see that this is a quadratic equation. Directly z square plus 3 iota is equals to 2 plus 3 iota into z minus 2 plus iota. Okay. So z square plus 3 iota is nothing but 2 plus 3 iota z minus, or you can say plus 1 minus iota minus 2, and you know what, this is 2 plus 3 iota. So I have multiplied this with z and this, correct or not? Okay, so this question is not very difficult, I would say. Z square plus 3 iota is equals to 2 plus 3 iota z, okay, and you have iota minus 2, okay. So 2 iota plus, sorry, minus 3, okay, minus 4 and minus 6 iota, okay. So z square plus 3 iota is equals to 2 plus 3 iota z plus, this is what, sorry, minus, by the way, this is minus 4 iota minus 7, okay. So now let us shift this to the right side. I am maintaining, by the way, I am maintaining the quadratic format. Z square, then we have what, minus 2 plus 3 iota z, and then we have, if you shift this towards the left hand side, you will have plus 7 iota is equals to 0. This is your quadratic. Now sum of all possible values of z square, again it is buffering or not? I don't see, no buffering. So z1 square plus z2 square is equivalent to alpha square plus beta square, which is what, z1 plus z2 whole square minus 2z1 z2. Okay, so sum square, so 2 plus 3 iota, finally the answer is 2 plus 3 iota whole square. Okay, this is alpha square plus beta square strategy, minus 2 alpha beta, 7 plus 7 iota, that's it. So let's just solve it. 4 minus 9, and this is plus 3 to the 6 to the 12 iota minus 14 minus 14 iota. Okay, so this is 4 minus 9, which is minus 5, and minus 5 minus 14 is minus 19. Okay, and then we have minus 2 iota. Can you see this is matching with option B? Okay, alrighty. Yes, perfecto. Another question on your screen, and you know what, this question you will see one important point over here, that z minus z naught is nothing but r. What does that mean? Can anybody tell me? What does that mean? Z minus z naught is equals to r if z naught over here, if z naught over here is the middle point or center and r is the radius, then z will be a point which is lying on this circle. So basically this particular thing means that distance between an unknown point z and z naught is nothing but r. Yes, distance between z, which is a moving point, z naught, which is a fixed point, by the way, in this case, which is the center of the circle, is nothing but r, which is radius of the circle. Okay, so please understand this particular format. Now understand, z be a complex number such that mod z is 1. Okay, fine. And this is what is given to us. Okay, so now let me do one thing. Let me solve it. 2 plus k square z is equals to kz. Let's multiply k plus z bar. Okay, so 2 plus k square z is equals to k square z plus k z bar. Anybody who is available, who is aware about the what do we say, hero property of complex numbers? Z bar is mod z square, which is 1. Very important. Z bar is mod z square. How many of you know this? And in this case, it is 1 square. So this is 1. Okay. So now we have 2 plus k square z. And you know what? By the way, one more thing, very clear. Although this equation looks slightly difficult, but can you see this equation is very easy now. 2 plus 0 is equals to k. That's it. So clearly k is coming out as 2. The moment your k is 2, now that you have this, then the maximum distance of k plus I k square. So 2 plus iota 4. 2 plus iota 4 is the point. Okay, maximum distance from 2 comma 4 from the circle. Okay, so this is the circle whose center is 1 comma 2, radius is 1, and now you have another point which is what? 2 comma 4, correct? 2 comma 4 is the point, and they are talking about the maximum distance between this point and the circle. Now please understand, maximum distance between point and a circle, this is 1 comma 2 and this is 1. Maximum distance between point and a circle, okay, this is 2 comma 4, will be what? Distance between the centers. See, maximum distance is this. So max distance, whenever they are going to ask, this is C1, C2, distance between the points plus radius of the circle, and if they are going to ask minimum distance, C1, C2 minus R. So maximum distance, everybody, distance between these two, square root of 2 minus 1 is 1, and this is 4 minus 2 square, 2 square, 2 square is 4, plus radius of the circle, so root 5 plus 1, root 5 plus 1 is option A. Okay, alright. Okie dokie, everybody. Another question in the same segment, in the same line, let's do it. Okay, alright, so this z1 minus this. So what they are saying is there is a point z1 which is an unknown point which lies on the circle, okay, whose center is 8 comma 2 and radius is 1, correct? Another circle whose center is what? If you take minus sign common, 2 minus 3 iota. So 2 minus 2 comma minus 3 whose radius is 2, correct? Minimum value of mod z1 minus z2. Mod z1 minus, what is z1? Z1 is nothing but any point which is lying on or inside the circle, because less than or equal to is there, no? So any point on or inside the circle is Z1. Any point on or inside the circle 2 is Z2, correct? Now you are looking for minimum distance between Z1 and Z2. So minimum distance or maximum distance, please listen, please understand, will always lie along the line joining these 2 points. Okay, line joining the center, minimum or maximum, both will always lie along the line joining both the centers. Now what will be the minimum distance? This is going to be the minimum distance. What is going to be the maximum distance? This is going to be the maximum distance. Can you see? This is the maximum distance and this is the minimum distance. Okay, now if at all minimum distance is asked, all you have to do is find the distance between, this is your R1, this is your R2. Find the distance between centers C1, C2. C1, C2 minus. Now please understand, minimum distance is C1, C2, but you have to subtract both the radius. Minus R1 plus R2. Ninja technique directly, and C1, C2 plus R1 plus R2 is equals to max distance. Okay, this is the final ninja technique. You don't have to draw it every time. Whenever you see any question in the examination which looks like 2 circles are given and minimum distance is what they are asking, then apply the ninja techniques, distance between centers minus sum of the radius. If at all they are asking maximum distance between centers plus maximum. Okay, so over here clearly minimum distance, if you are looking for distance between centers 8 comma 2, so square root of 8 comma 2 and 2 comma minus is 36, plus this is 2 and minus 3, so 36, 2 and minus 3, right, sorry, minus 6, 2 and minus 6, so 2 and minus 6 is 64, okay, minus radius 1 plus radius 2 is 3, so this is root 100 minus 3, so 10 minus 3, 7, where are you? 7, option C is absolutely correct. Okay, alright, we are learning the concepts with the help of PYQ. So wherever the question is demanding any concept, I am explaining you that. Okay, now this particular question again from What do we say? This question, everybody, this question, right? Alpha plus iota beta, gamma plus iota delta are the roots of this equation, right? So clearly, if we see that x square 2 iota minus 2, okay? Now one hack I will tell you. You know what? See, sum over here is given as 3 minus 2 iota, and product of two things is given as minus, or you can say directly 2 minus 2 iota. Sum of two roots is 3 minus 2 iota and product is this. Can you understand what kind of roots will there be? Okay, with the help of judgment only you can actually do that. 3 minus 2 iota will be 1 plus 2 minus 2 iota. So if you have two roots, this as alpha and this is your beta. Okay, all right. This is your alpha, or you can say this is first root and second root. First root this, second root this. Even if you multiply, you will get this. So now what does that mean? You have actually got two roots. That's it. Easy peasy. First root of this quadratic equation is 1 plus 0 iota, which can be alpha plus iota beta. And second root will be 2 minus 2 iota, which is gamma plus iota delta. Okay. Now alpha is equals to 1 comma beta is 0. Gamma is 2 and delta is minus 2. Okay, alpha gamma you have, which is 2, and beta delta will be 0. So answer of this question will be just 2. Yes, probability will do that. Okay, but not right now. These kind of questions as well, okay, which says that number of complex numbers satisfying this equation. Please understand there is some error in this question. I'll correct it. It is z upon z bar plus z bar upon, this is not z bar, this is just z, okay. Otherwise these two will get cancelled out. Huh? Yes, this is 1. Number of complex numbers satisfying this, okay. So now let's just cross multiply. This is z square plus z bar square whole upon z bar is mod z square, hero property, which is 1. So that's it. This is just 1. Okay. Now z square. Okay. Z square plus z bar square. So everybody, z square is what? X plus iota y whole square. Z bar is x minus iota y whole square. And this is 1. Correct? Now, if I open it, it is going to be 2x square minus y square is equals to 1. So, x square minus y square is half. Okay, right? X square minus y square is actually half. So, now what they are saying is number of complex numbers satisfying this and this. So, what is this? This is an hyperbola. This is a hyperbola. Correct? This is a hyperbola. Modulus is there. Modulus is there, right? So z square, okay. And you know what? There is a modulus involved, so that there will be plus minus. Okay, what does that mean? These are the two hyperbolas, by the way. So first of all, we have a circle that is fixed. Now, if you have x square minus y square is equals to half this as hyperbola, 4 solutions. And you know what? If you have a circle again, but now you have this hyperbola, 4 solutions. So 4 plus 4 is going to be 8. Total 8 solutions will be there. Yes? Okay. So this is how it is going to be. Total 8 points. Alrighty, everybody. Yes, now I am finding some good questions from complex numbers to solve it. Do we have? Yes. One more question we can check. Okay. Yes. Yes, Louis, I have watched it. Yes. Absolutely. Why not? Why will I stay? Being a maths teacher, why will I stay away from these channels? Okay. Yes. And super soon you will see some brainstorming mathematical things from my side also. Reveal. Ninja ma'am has just revealed something. Okay. Okay. All right. Now, S1 and S2. Can you see? Z minus iota upon Z plus iota is purely real. Okay. So, you know what? What is purely real condition and purely imaginary? Purely real. Purely real and purely imaginary. Okay, if a number is purely real, that means Z is equals to Z bar. And if it is purely imaginary, Z plus Z bar is 0. How many of you know this? Yes? How many of you know this? Okay, so now statement number 1 says that you have a complex number which is not minus iota. Minus iota is rejected, correct? And mod z is 1 and this is given as purely real. Okay, this is given as purely real, correct? So if this is purely real, that means z minus iota upon z plus iota is nothing but z minus iota upon z plus iota complete bar. Now please understand, I'll apply the property of conjugate over here, that if any complex number has a complete bar, it can be actually applied, that conjugate can be applied on this individually, right? Z minus iota and Z plus iota. And now again, if at all you want further apply a property, so it is going to be, please understand, on the right hand side, this is Z bar plus iota sign change because of the complex conjugate, and this is Z bar minus iota, and this is Z minus iota and Z plus iota, correct? Now this is what you have. Now cross multiply. If you are going to cross multiply Z bar, can you see mod Z is 1? So Z bar is mod Z square, which is 1. I am cross multiplying. Then you have minus iota Z. So minus iota Z. Then you have, okay, minus iota Z bar, and then you have minus plus iota square, so it is minus 1. And on the right hand side again, this is 1 and this is what? Can you see? Plus Z iota plus Z bar iota, and again this is what? Minus 1. So 1 minus 1 anyway is gone. And now clearly if you shift this towards the right hand side, so this is 2 iota Z and plus 2 iota Z bar. That's it. So it is going to give you Z plus Z bar is equals to 0. Z plus Z bar 0 means what? That means Z plus Z bar. So this is x plus iota y and x minus iota y is 0. What does that mean? X is equals to 0. If x is 0, okay, x is 0. Okay, if x is 0, my dear students, so your complex number is purely Z. I am talking about Z. See, if x is 0, your Z is going to be what? Iota y. Z is iota y, and since mod Z is 1, this y is also 1. Okay, so or plus minus 1, so Z is going to be plus minus iota. Now please understand, Z cannot be minus iota. Z cannot be minus iota. If Z is not minus iota, then only one option I have left, Z has to be iota. And if Z is iota, that means exactly 2 elements is false because Z is just iota. One single element is coming. So clearly S1 is wrong, false statement. And similarly, you have to solve statement number 2 now. Statement number 2, everybody. Now it has become a very easy question. They are saying that z minus 1 upon z plus 1 is purely imaginary. Z minus 1 upon z plus 1. If this number is purely imaginary, that means this plus this bar is equals to 0. Can you see the condition of purely imaginary? That complex numbers plus z bar is equals to 0. That's it. So z minus 1 upon z plus 1 is equals to, this is what? Not equals to, but plus z bar minus 1 upon z bar plus 1 is 0. Now this is z bar is mod z square, which is 1, plus this is z plus z bar plus 1. And if you do this, this is z bar is again 1. Okay, then it is plus z, then it is minus z bar, and then it is minus 1. Okay, plus z bar is again 1, minus z. Okay, then it is going to be what? Please understand. Z bar, then minus z plus z bar minus 1. Okay, this should be 0. So this is denominator. Now let me just do this. 1 minus 1, 1 minus 1. Z minus z gone. Z bar, okay. Z minus z gone, minus z bar plus z bar gone. So this is anyway 0. Okay. Can you see that I was trying to find out on what value of z this is coming? So this is anyway coming 0. That means all values of z, there are all values of z. This is valid for everyone. This particular thing is valid for every z. What does that mean? Infinite many elements. That means S2 is absolutely right. Okay. So correct. So statement 1 is wrong and statement 2 is right. Statement 2, only statement 2 is correct. Option C is absolutely right. Yes, Louis, you have absolutely answered this absolutely correctly. Okay. All right. Clear? Now what we are going to do is we are going to take a halt. Complex numbers, binomial and quadratic we have done and dusted in this session. The next thing is something which is sequence and matrices and determinant, that we are going to continue in the next session. Okay, so I'll inform you whenever I am going to plan that session. Okay, so yes, and also please do not forget that you have yes, can you see that your Ved AI PDF is there in the description box? So yes, all right, you can actually check that out. And yes, ma'am, why did you change your hairstyle? Is my hairstyle changed or what? What happened to my hairstyle? Nothing. I have just tied my hair, and because whenever I do mathematics, I don't want my hair to irritate me. Chalo, bye. Such a girl's thing. How many girls in the chat box, by the way? Probability also, yes, we'll take. Okay. Lewis Hamilton or Max Verstappen? What do you want? I don't know. But Lewis Hamilton is more sayable. Okay. Chalo, bye. Good night. Yes.